Hello guys, in this video we are going to take some of these problems and we're going to try to resolve them. First, I would like to start with this problem that we have here. Okay, so this problem tells me, consider the polynomial function h of x equals minus 2x to the power of 5 plus 8x to the power of 4 minus 2x squared plus 15. Okay, and this we're talking about, let me highlight it with a different color. I love color coding stuff. The end behavior of the graph of h, or in other terms, the end behavior of polynomials. That is this lesson. How do you approach this? Well, before we start, let me just go ahead and read the first part. So this is how we read this. As x approaches infinitive or tends to infinitive, h of x tends to positive infinity. Okay, let me read this again. As x uh, approaches positive infinity, h of x approaches or tends to positive infinitive. And as x approaches or tends to negative infinity, h of x approaches positive infinity. Okay, let's see how that is true. Now, think about end behavior. A polynomial can be seen as the sum of several monomial terms of different degrees. You have it here. Negative 2x to the power 5 plus 8 to the power of 4 minus 2x to the power of 2 plus 15x to the power of 0. You know that anything to the power of 0 equals 1. Okay, so as the input variable gets larger, so like as these variables get larger, or positively or negatively larger, the lower degree terms become insignificant in comparison to the term with the highest degree, which is called the leading term. The leading term. And this is true because if you have 1 million, if you have 1 million um, raised to the power of 5, this is way larger than if you had 1 million raised to the power of 2. In this case, you see that um, this is going to be a 30. This is going to be raised to the power of 30. And this will be raised to just the power of 12. So 30 is much bigger than 12. Okay, so this is completely true. Now, therefore, in order to determine the end behavior of a polynomial, we consider its leading term. In particular, whether its degree is odd or even. Okay, so let me highlight this part. So leading term and its degree is odd or even. And whether its sign is positive or negative. So these are the three things to consider. Leading term, whether degree is odd or even, and whether its sign is positive or negative. Now let's take a look at the problem here. Okay, let me delete this part so that you are less confused. Okay, so in the case of h of x, which is the function that we're given, or the polynomial, the leading term is negative 2x to the power of 5. Okay. Um, and you know that x to the power of 5 goes to positive infinitive as x gets positively large, and goes to negative infinitive as x gets negatively large. That this is true if we take x to the power of 5 and we say x is, I'm going to say a ridiculous number, 1 trillion, which we would write it as this. As you can see, this number gets infinitively big, gets really big. And if you, instead of a trillion, you have more than that, it will get extremely big. If you write this in a calculator, it's going to give it to you in scientific notation because it's such a big number. So this is what it's telling you. And if you see, because is odd, because this number is odd, it will be, if you have a, for instance, instead of 1 trillion, you have negative 1 trillion. Okay, negative 1 trillion. This number here would be negative. Okay, so negative, um, because the odd number is negative. If you think about it as multiplying the sign, you have an odd number, so the signs will multiply each other 5 times. And you can think about this as positive, positive, because negative times negative is positive, and then positive times positive is positive, and then positive times negative is negative. So that's why you will have a negative sign here. Okay, so let's go then and finish with this problem. Okay, so now you know that the three things that you need to understand or to take into uh, consideration is the leading term, the degree, if the degree, whether the degree is odd or even, and the sign, whether the sign is positive or negative. Okay, so in this case, if we analyze it, you know that we already know that this, when x to the power of 5 um, tends to positive infinity, so when x to the power of 5 tends to positive infinity, um, this will get infinitively large and it's going to be positive. Okay, but you have this multiplied by a negative number, which is 2, and so positive times negative is going to be negative. So negative infinity. Okay, so negative infinity. When, so you could say, uh, simply put, as x tends to positive infinity, h of x tends to negative infinity because of the coefficient, the negative coefficient here. And as x tends to negative infinity, the polynomial tends to positive infinity. Okay? Because in the second part, well, if you have, let's really think about the leading term. If you have this negative 2 and you substitute by a negative infinitive, just think about the signs really. Remember that an odd sign will give you a negative number. And so negative times negative is positive. So you end up with positive infinity. And when you have positive infinity, you don't have to write it. So positive infinity. So um, our polynomial would be um, as h, so it will be b, as x approaches infinity, h of x tends to negative infinity, and as x approaches negative infinity or tends to negative infinity, h of x tends to positive infinity. Okay, so that would be your answer. Okay, that's all for today. I know this video was a little bit long, but I hope that I was able to explain the whole process. I'll see you guys on the next one. Mr. Luna out.